We'll see if it goes better this time. Okay. So density, I'm hoping that you guys know that it is. In this room. Because it keeps the AC, it keeps the heat up, it keeps the cold in. Did you guys know that other side of the hallway is not air conditioned? And their heat comes over here. Yes? So we do not want that heat in here. We want to keep this classroom nice and cool, so we're going to keep the door closed. Excellent. I have 2 more people. That's very exciting. Okay, so we are on page 65. And I'm hoping that all of you, you know, from grade 8, 9, 10 know what density is. It is the mass divided by the volume, okay? And the formula, you can either use a lowercase d or you can use an uppercase D, it doesn't matter. The m has to be a little m for mass, and the v has to be a big V, okay? Little m, big V. All right, and so now we are going to do a couple of examples which you have written for you there, but I'm going to do over on the side. I think I am. Where did they go? They were here. I put them here. Ah, there we go, an iron bar. Excellent. So an iron bar has a mass of 19,600 grams and a volume of 2.50 liters. What is its density? So if I were to write 19,600 and divide by 2.50 and throw that into my calculator, 19,600 divided by 2.5, I get 7,840, and I'm done, right? Oh, okay, I'm not done. I need my units, so I need to have my grams and I need to have my liters. Okay, and I also need to, in my final answer, have my grams and my liters. But I'm missing something else. I am missing the formula. Okay, so anytime you're solving a problem, whether it be in chemistry or physics, you should write the formula first before you plug in the numbers. Is good? Okay, you will not get full credit if you do not write the formula. It's like if you were to write half a sentence, just the second half of a sentence, I could probably figure out what you mean, but it would be like much harder for me to interpret. Yes? If I look at a sentence that says that, I can take in all that information in just like a split second, right? Whereas if I just see half of it, it takes me a lot longer to process what I'm looking at. Okay. Now we are going to be using density as a conversion factor. We're working up to using this in the context of moles, okay? But using density as a conversion factor. If mercury has a density of 13,600 grams per liter, what volume in milliliters, that's our unknown, is occupied by 425 grams of mercury? Now, anytime we see a slash notation like this, it means we should be rewriting it as 13,600 grams over liters, because that way we have a unit on the top and a unit on the bottom, and we're not going to get mixed up about where those liters are. Okay, so this is a conversion factor. That means that this other number must be our initial quantity, and this is our unknown here. unknown is equal to the initial times the conversion factor. So we don't know how many milliliters. Our initial quantity is 425 grams. And what do you think of what I've done here? Oh, I have to convert to milliliters. Okay. Ah, yes, I have to put the grams on the bottom. It's not going to work if I leave it like this. I have to flip it upside down. Okay, 600 grams per liter. And then I want the volume in milliliters. So if I want the volume in milliliters, I need to cancel liters and find milliliters. And I know there are 1,000 milliliters in 1 liter. Okay, we do that, 425 divided by 13,600 times 1,000 equals 31.25. And because I only have 3 sig figs, that would then become 31.3 milliliters. Yes? Okay. Now we're going to move on to 5.4b. We're not actually going to do any problems on this today. This is on page 71. Because we're going to connect density to the mole. If you are given the volume of a solid or a liquid or a gas, not a solution, okay, not a solution, but a solid, a liquid, or gas, you can find its mass by using the density to do the conversion. So volume could be in liters, okay, and grams is obviously grams, and density could be grams per liter, so it would allow you to convert between grams and liters. Or volume could be milliliters, and then you would have to have grams per milliliter, or do a conversion between milliliters and liters. Okay? And once we have that, once we have grams, we can connect that to our new unit, the mole, because if we know grams, we can find the moles. Yes? Because now we know about molar mass. So if I give you a volume of a solid, you can find the number of moles in that solid. In fact, you could find the number of molecules in that solid. Okay? Now, just to be a little bit more complete here, remember I said this was only if we had a solid, a liquid, or a gas. If we have the volume of a solution, we can only find that from moles. And what do we use to convert between moles and volume of a solution? Molar mass, that would find grams. Remember, volume is liters and moles is moles. So you need something that converts between moles and liters, which would be molarity, moles per liter. Okay? So solutions are different than solids, liquids, gases. All right? Solids don't really have a concentration. You cannot make a solid more concentrated. Yes? Like, how would you do that? You can't squish it like it doesn't squish, right? You can't make it more dense than it already is. Essentially, its concentration is its density, which does not change. Same thing with a liquid. You cannot change the concentration of a liquid because you would have to squish it, and it doesn't squish. Gases are a little different, but we'll talk about those another time. Okay, so there we go. All right, we have a couple of questions here, which I think I put here. Did I not put them here? What is wrong with me? That's okay. I will just go here because I know I have them here. Okay. So we have these questions are just right here. Yes? Okay. But I'm going over here because I don't want to, I want to write it for myself, okay? So we want to know how many moles, and this particular chart that I have here is actually from page 3. So if you ever want, you can actually, if you don't like flipping back and forth, you can actually tear out page 3 and just have that in front of you if you prefer, okay? But anyway, we want to find the number of moles. So this is where we are aiming, the number of moles. Are contained in 23 milliliters, so that is a volume. We are starting with 23 milliliters of ethanol. And you'll notice that this ethanol, what type of substance is it? It is a liquid. So that means we can use density to get to mass, okay? Because we have a liquid, that's one of our things there. We can use density and we can convert our milliliters into grams. So we're going to take 23 milliliters, we're going to convert it into grams, and then we're going to take our grams and convert them into moles. And if you find this little chart helpful, like I said, tear out page 3 and have it in front of you. Yes? This is on page 71. Those boxes are not there. So if you want that chart, take page 3, tear it out, and have it in front of you. Although I think I printed one out for you, so you might actually have it separate already. Did you? Did I? No, that was my other block. Never mind. It was just they were in the same seats as you, so I had it confused in my head. Yeah? Or you can tear out page 3. Okay, would you like me to tear out my page for you? Here. Are you sure? Okay. For Monday, what I'll do is I'll get everyone who wants one a copy of it, okay? So it'll all be printed out so you don't have to flip back and forth and you don't have to tear the page out of your book. Oh my God, okay. All right. So we're gonna go start from 23 milliliters, so we're trying to find moles. We're starting with 23 milliliters. Oh, 23.0, sorry, milliliters. And we want to find the grams, which means we need to cancel grams and find milliliters. So, did I do that right? No, I did not. I put the units in the wrong place. Oh my goodness, Friday afternoon is being a little bit not so kind to me. That's all right though. There we go, grams per milliliter. And do we have that quantity? Oh, look at that, it's right there. Yes? 0.789 grams per 1 milliliter. So now we've done step number 1. We have converted from milliliters to grams, and now we need to go from grams to moles. What do we use to go from grams to moles? Molar mass, and where do we find that? On the periodic table. So we would need to go to the periodic table, and we have 2 carbons, we have 6 hydrogens, and 1 oxygen. So that's 2 times 12, and we have, that's 24, and we have 6 times 1 is 6, and 1 oxygen, 1 times 16 is 16, and we add that up and we get 16 to 1, 46. Are you happy with how I've written that molar mass? What's wrong with it? I need units. And what are the units for molar mass? grams over moles. Is there anything else I could do with that molar mass that would make it better? I might need to flip it, we'll find out. I need another sig fig because these numbers, even though I got lazy and I did not write my point zeros, these numbers all actually have a point zero. So in order that I don't just have 2 sig figs, because it's better to have 3, okay, we're going to use the 46.0 grams per mole. So let's cancel our grams. They were on the top, now we need them on the bottom, and find our moles. So where does the 46 go? On the bottom with the grams, 46.0 grams per 1 mole. Let's do that calculation. 23 times 0.789 divided by 46 equals 0.3945. And the only unit that I have left is moles. Now, before I do that, I need to say I have 3 sig figs, 3 sig figs, 3 sig figs, so my answer should have 3 sig figs, so 0.395 moles. Good? Okay, we're going to go the other way now, backwards. So that we went from moles to, we went from volume to moles. Now we're going to go from moles to volume. So if we look at our little chart again here, we would be starting at moles this time. Okay, we have, what's our number there? 8.35 moles. 8.35 moles. And you'll notice what type of a substance is aluminum? It's a solid, so that tells us we can use density to get to volume. Okay, so we can go from moles to grams. Ooh, what happened? We can go from moles to grams using the molar mass, and then from grams to either liters or milliliters, depending on what we've got. Okay, so let's try it. What is the volume? Do you think we want to do milliliters or liters for our volume? What's that? You could, or you could say, look, I have milliliters in my density. And so if I stuck with milliliters, I wouldn't have to do an extra conversion. If it doesn't say specifically, you can choose which one, okay? So in this case, I'm going to say how many milliliters. If I chose liters, though, that would be perfectly fine also. All right? And we are starting with 8.35 moles of aluminum, which is a solid, which is why we can use density. What are we converting moles into? We want to eventually get to volume, but before we get to volume, first we need to convert to grams. So let's cancel our moles and find our grams. And that's grams per mole is found where? Periodic table. Molar mass of aluminum is 27 grams per mole. And now we have 8.35 times the, oh, my brain just turned off for a moment. Now that we have grams, what do we want to do next? We want to find the volume. Do we have a conversion factor between grams and milliliters? Yes, we do. It is right here. Yes? So we have grams on the bottom and milliliters on the top, 2.70 grams per milliliter. And we get 8.35 times 27 divided by 2.7. This is going to be a nice number because those both divide by each other. 83.5. I find that weird that the molar mass is 27 and the density is 2.7. Just a weird coincidence, right? So yeah, anyway, it ends up making the math really easy when you're doing density and molar mass with aluminum. Anyway, grams cancel out and we are left with milliliters of aluminum solid. Okay, can anyone think of another way to express that? Often with solids, instead of using milliliters, what's the other unit of volume that's equal to a milliliter? It's a centimeter cubed. Okay, so if you wanted to, and you certainly do not have to, you could write that as 83.5 centimeters cubed of aluminum. But like I said, not necessary. We are not going to do any problems with density today. I've just sort of set this up so after Monday's quiz you can do some of the problems, okay? One thing is for Monday's problems, if you're doing the more challenging ones, you might need to remember mega, kilo, deci, centi, milli, micro, nano, 6, 3, 1, 2, 3, 6, 9 is for the nano. Which of those are negative? 1 to 9. Okay, and what that means is, for example, if I have 1 megagram, because remember the 1 goes with the prefix, right? Yes, okay, so the 1 goes with the mega. That would equal 10 to the what grams? 10 to the 6 grams. If I had 1 microliter, that would equal 10 to the negative 6 liters. So if you're doing the more challenging questions on Monday, you might need to remember those. Okay, so that was just a little quick review there. But for today, if you are not taking Chem 12, you can just work on those, okay? We're gonna have like a little section where we do the procedure. I will call you back so you know that we're doing the procedure bit. All right, the procedure is just how do you make a solution? Yes, which is what we did yesterday. Yes? Okay. But for now, we're going to go to Dilutions II. Okay. Dilutions II. Oh, there we go. Okay, I'm a little confused. Oh no, that's fine. That was from yesterday. Okay, here we go. So we're going to go to page 5 of Dilutions II. All right, and when water is added to concentrated acid, we can run into a little bit of problems. You remember how last day, if we wanted to dilute a solution, what we did is we measured out, I'm really regretting drawing the volumetric pipette right now. They're really hard to draw. Okay, we measured out a certain volume of the stock solution, yes? And right now, if you're doing the grade 12 stuff, this is one of the procedures that you might be asked to do on Monday's quiz, okay? So you would measure out certain volume of stock solution. How do we find that certain volume? First, we find the moles. needed in the dilute solution. Maybe I should put an A there instead. Dilute solution. And B, we then find the volume of stock that contains that number of moles. Okay, that's the mathy bit. That's not the procedure bit. You would not need to write that out if you're giving the procedure, okay? So we'd measure out that certain volume of stock solution. We would then, what would we do with it? Where would we put that stock solution? We would put it into a volumetric flask, yes. So you would take the stock solution and put it into a volumetric flask. That's step 2. Step 3. Now we have our volumetric flask with the stock solution in it. What would we do next? We put a stopper on it right now. We have to do something else first. Because all we've got right now is stock, and remember, we are trying to dilute the solution. Yeah, we have to add water. Where do we add the water up to? Yeah, so we're going to add water to the line. Add water up to the line. Okay. And I will let you know that if you're practicing this over the weekend, they've actually shown that one of the ways of remembering things well is to draw them, right? So you might want to practice drawing these little pictures, right? Even if on the quiz you're like, I don't want to draw, I just want to write, you can write on the quiz or you can draw, and it gives you like, it uses different neurons, and so you have more neurons to draw on to remember things, right? If you just write it, you only have verbal neurons. If you have the picture neurons, it's much more, you got a lot more places where that memory is stored. All right, so we're going to add water up to the line. In goes the water. Okay, that's my water. The reason I don't teach art. Okay, so here's now we have our water all the way up to the line. Our line. What do we do now in step 4? We shake it, but before we shake it, we have to plug it up, and we're going to use a stopper, okay, which is usually like black rubber. And once we've done that, we are going to invert it, turn it right side up and upside down to mix. And then we're done. Is good? Okay, now the problem is, if this stock solution, that yellow solution right in step 3, if that were an acid, if we add water to it, the mixing process is very exothermic. What does it mean to be exothermic? It produces lots of heat. And sometimes if you produce lots of heat in a very short amount of time, the glass can crack, yes? Which is not good. The other thing that can happen is that liquid, which has a very small volume, if lots of heat is produced, the temperature will rise very, very significantly. And you might even get to the point where it boils. And if it boils, then it's spattering around. Maybe you get hit in the face. Nobody wants that, right? So when we do an acid, instead of putting the stock solution into an empty flask, we're actually, what do you think we could do first? We could put some water in the flask first. And what that water does is when we add the acid, heat is still produced, but water's really good at absorbing heat, right? That's why if you live near the ocean, the temperature is a lot more moderate than if you live like on the prairies or whatever. Okay, so if we have, so to dilute an acid, we would actually start with the flask filled a half to a third with water. A half to a third, a half to 2/3, sorry. Okay, so here we go. We got our water. And then the second thing we're going to do is now we're going to add in the stock solution. So that's step number 2. Add in the acid stock solution. Okay, and that's going to be like yellow. Yes. So what we will end up with then is we will end up with our water, and then our small amount of stock solution. Yes? What do you think we should do with this now? I can add more water, but before I do that, I probably want to swirl it, okay? Swirl to mix. All right, and now that it has been mixed, now we can add the rest of the water, right? We now have the mixed stuff, which, oh, look at that, I've combined my yellow and my blue, and I've made green. Oh, so clever, right? And then I'm gonna add water to the line. And then finally, guess what? we're going to go back down here. Yes, because this is going to be the final step regardless. Yes, this is always the final step. Now, what I'd like you to do is I would like you to take a moment and I would like you to draw out with labels the procedure that you did last day, where you're starting from solid, okay, rather than a liquid. Okay, yeah, I want you to draw it and label it, the procedure. Where would you, just grab a piece of paper. You can do it wherever you want. I would get myself a whole piece of paper because I can't draw small, but you can draw it wherever you like. There's probably actually room on the very back page of Dilutions II. There's nothing on it, so you could draw there if you want to. So those of you who are not taking Chem 12, you could do this part too, because this is part you need to be able to do. Everybody should be doing this. I'm making this worse and worse. kind of the steps I did. Add the correct mass of solid to the beaker, pour the solid through into the flask through a powder funnel, add water to fill the flask until it's about halfway full, maybe 2/3 full. Swirl it until it's all dissolved. Now it's all dissolved. We add water to the line. And then what do? We stop the flask and invert to mix. Yes, always. Now I've made it invisible. Okay. Oh, I can control Z, control Z, 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 Z. Okay, is good? Okay, we're gonna do a mathematical type problem related to this. And I don't like this question, and it is not anywhere in your book, so we are going to try a different one. All right, what we're going to do is we're just gonna write it out. What volume of stock solution, of 8 molar stock solution, so you can just write this anywhere. This is not a question that's on any page. Would you need to prepare 500 milliliters of 0.25 molar HCl solution? First step in any dilution problem is find the what? Find the moles. Okay, step 1. Find the moles. I want you to look at those 3 numbers, and I want you to choose 2 of them that will allow you to find the number of moles you need. So have a chat with your partner and decide which of those 3 numbers do you need to find the number of moles you need. Which 2 would you like? The 8 and the 0.25 and the 500? Okay, what do I have 500 milliliters of? I have 500 milliliters of 0.250 molar. I do not have 500 milliliters of 8 molar. Yes? So the 500 can only be used with the 0.25 molar. Okay? So these 2 have to be used together. And that's what I want, right? I want 500 milliliters of 0.25 molar. Yes? what should I rewrite 500 milliliters as? 0.500 liters. And if you're given a round number like 500, you can assume that that doesn't just have one sig fig, because that's ridiculous, right? You'll be making it up in a 500 milliliter volumetric flask, which probably has lots of sig figs. So just assume that even if we don't draw a dot after it, you've got 3 sig figs. How should we rewrite 0.25 molar? 0.25 moles over liters. So you have to make sure when you're doing these dilution problems that you're matching up the volumes, yes? Do you see how we have the volume of my diluted solution, and this is the molarity of my diluted solution? Those two go together. Whereas I'm saying, what is the volume of my stock solution, and this is the molarity of my stock solution. Those two go together. Is good? Okay. So now we have these two numbers. Could we find the moles? That's what we want to find. Can we find the moles? Yes. Okay, what we're going to do, we want to find the moles, and that is equal to 0.500 liters times 0.25 moles per liter. So we have 0.5 times 0.25 equals 0.125 moles. That's how much moles I need to make my final diluted solution. Step 2. We're going to find the volume. What are we finding the volume of? Let's go back to our question. What solution are we finding the volume of? We are finding the volume of 8 molar stock. So we want the volume of the stock solution. Okay, so for this second part, we don't know the volume of the stock solution, but we do know that the concentration of the stock solution is 8 molar. How should I be rewriting that? Yeah, and I guess I should put my 2 zeros in because I forgot about them, but there we go, 8.00 moles per liter. And we want to find the volume of the stock that contains a particular number of moles. How many moles do we need our stock solution to contain? I need it to contain 0.125 moles, because that's how much I need in my final solution. And remember, moles before dilution are the same as moles after dilution. So I want those moles right there, 0.125 moles. So now I have 0.125 moles, and I have 8.00 moles per liter, and I want to find the volume. Could I use the two numbers in boxes to find the volume? Yes? What would I do? I want to find the volume. What would I write first? Would I write 8 moles per liter? No. Start with your initial amount. It's easier if you start with your initial amount and then write the conversion factor, because sometimes if you write the conversion factor first, you won't write it the right way around because you haven't figured out what it needs to cancel with yet, okay? So let's write our initial quantity, 0.125 moles first, and then times 8.00 moles per liter. No, why not? Because I would have moles squared over liters, and that's ridiculous. 1 liter over 8.00 moles. That looks so much better. And we do our division, divided by 8 equals, and I get 0.015625 liters. And if you were to answer that and then round it to correct sig figs, 0.0156 liters, on this test, because you're in grade 11, I would say that's probably okay. But if you wanted to be really sophisticated about it, you would say, what am I going to use to measure out that amount? And would it be better to leave it in liters, or to change it to milliliters? Better in milliliters, yes? How many decimal places do we move to make it milliliters? 3. Do I move it to the left or do I move it to the right? I move it to the right 3 places. 1, 2, 3. And that gives me 15.6 milliliters and 15.6 milliliters. And that is a nice number. That's something where I could go and get my 25 milliliter graduated cylinder and measure that out, and I could pour it into my flask, and then I could dilute it. Yes? All right. Homework is there. Like I said, we're doing nothing with density, okay, because we don't want to. And I'm so sad because I thought that lesson went quite well compared with this morning's lesson, but I think I forgot to record the picture. Oh, so I'm going to press stop.